Thank you, Resma, for the nice intro. So the talk today is MLops from concept to product. I'm very happy to be talking about this because I feel that this is what any data professional love to do, would like to do, is to deploy data products in production. So what is this talk about? We will have an overview of the best practices that we're following currently. And by the end of the talk, we hope to answer these questions. So what is MLOps? Why should we follow MLOps practices? What do we need to do MLOps? And how can we start the process in our companies? So first, what is MLOps? Is the process of using machine learning models as useful because we want to give value to users, verifiable because we want to be sure that whatever our models are predicting is trustworthy, and evolvable because, of course, as any product, an ML data product has to change according to the user requirements and whenever the technology changes. MLOps is an agnostic practice that is very important to have clear because it doesn't depend on the language that we are using or the infrastructure that we have in our companies or the application that we are building. It's a set of practices and we can always follow them. Another way to see MLOps is like the application of DevOps to the machine learning workflow. So for that, then we have to first know what is DevOps. DevOps is a practice also in the software engineering space, and it's about automating the whole life cycle to deliver software. And this became so important because of agile principles. So the idea is that continuously the team is coding, releasing new products, and we can get feedback fast from the users. And this is meant to improve the quality of the product that we are delivering. So we do that following, but having three different aspects. There is people. In people, then we want to have cross-functional teams where we have developers, backend developers, front-end developers, and operations, so that a small team can really deploy things that are usable by users. The process, then we have small sprints that are normally 2 weeks, where we have small packages, and we want to finish that. We want to give value to the users in this short period of time, and we need, of course, tools. For what? Because we want to automate all the process, so that as soon as developers are coding, whatever they are adding to the product can be easily built and deployed. And of course, then we will have to be monitoring this, whatever we are building, so that we can get feedback input for the next iteration of the process. A topic that is closely related to DevOps, that is also a set of practices, is continuous integration and continuous delivery. Then this, when we're talking about integration, is to be sure that we have software that is ready to be deployed. So everything that the developers are doing is combined in one repository. So all the code is together tested. So we know that the code works properly or is not going to break anything. And we can deploy it in the moment that we want. To do that, then we have to follow test-driven development. That is that every time that we are coding, we need to have tests, and be sure that every time that we're adding new code, this code is tested. And that is, in that way, we can have decentralized deployment because anyone can deploy. So there is no risk that if a person makes a mistake, this mistake will go to production. For that, we also need to have production-like staging environments so that we can test everything before in an environment that is very similar or equal to the production environment to be sure that once it's in production, it will work in the same way. So this is what is DevOps. Now we'll talk about machine learning systems and why they are different. This is the machine learning lifecycle that many of you know. So normally we start defining a use case where we define some metrics, what are the things that we want to improve in the company, and how can we do it. And we define that business case as a machine learning model. After that, we have to explore the data. So we have to be sure that we have enough data and the data is of quality. And we start experimenting, seeing different options, different models, and doing feature engineering, depending on the use case. But most of the time, we will need to do some feature engineering. We will evaluate if this option is possible. We'll present the results. If we find a solution that is better than whatever the company has at the moment, once we present and we get the approval from different stakeholders, then we can deploy the model. For that, we have to find a way to integrate that model within the services or the product that the company has. And we have to monitor the model and see if it is performing how we planned. And this is the whole cycle, or more or less what we have to do if we start working in a company and there is not MLops in place. So now let's talk about the team. So normally in a data team, we have different profiles. Some are more business oriented. Some roles are more technical, some more towards like what is software engineering. That is the case of the ML engineer, which is the one who is in charge of MLOps topics, and the data engineer. So we have the data scientist. That is a person who has more knowledge about algorithms and statistics and can find the best solution for a problem. And similarly, we have the analytics engineer and the data analyst. So in most companies who start doing, starting to do data science, before they used to hire first a data scientist, then after they realized that to start doing data science, they need a data engineer to get the data in a better shape, or they need also an ML engineer so that whatever the data scientist is doing can really be deployed in production. With that, now let's see, we'll see why are MLS machine learning systems different. So the first most important difference is, of course, the data, because that brings a lot of challenges. It's not the same to deploy a software or that is only code, and compared to deploying an ML system, with the data, largest amount of data need to be used, and this implies a lot of resources, computing resources. Also, because of the nature of ML models, it's difficult to define and measure what is success, because it's not, most of machine learning models are not deterministic, and they are poorly understood. This is not like an ML engineer or a data scientist can understand them, but other people in a company won't be keen to understand or it will be difficult for them to do it. Another difference in the team skills. So as we saw before, we have different roles in a data team, and some of these roles are not don't have the skills to deploy things in production or products as a software engineer or a backend developer could do it. For that end, we need to have the tools in place so that whatever data scientists do can be deployed. So now let's see the different challenges that we have in the dev process and what makes machine learning systems really different to any other kind of software. So first is experimenting. So due to the nature of different machine learning models, we always have to experiment to find which features we're going to use, which algorithms we're going to use, and the best hyperparameters. And we need to have a way to store all this information and to be sure that we are selecting the best option. For that, we also have to be sure that we are able to reproduce the models, because if I'm working in my local machine, I get good results, I want to get the same good results when we are in production. So we need to reproduce for deployment and also for debugging, because if there is an error, we also want to check that what is the cause of the error. For that, we have to be sure that we have the same inputs, so the same data, the same code, and the same parameters. We may need to have remote storage if there are multiple people working in the same use case. So we have to be sure that we are all seeing the same data. And we need to have the same environment. So for that, most of the time we use containers to be sure that we can reproduce the same environment as it was done maybe in development or in production. And we should try to reduce any non-deterministic behavior. So we have to, for example, set seeds so that if we execute the same process with the same inputs, we are sure that we are getting the same output. Here, it is important also to mention tracking and versioning. So which is related to both experimenting and reproducibility, because if we keep record of all the inputs and also we track the metrics, if we can't check if we are selecting the best model. We can also see what are track the metrics of the system. So what was the time that it took to train the model, and what was the RAM needed or the CPU usage, because this is important to know that we are doing that we can plan the resources that we will need in production. Another topic that is closely related to tracking is Git for data science. So Git, of course, we can use it for versioning. So apart from the code, which we do for any software product, we also have to version the data and the model artifacts. Model artifacts is the output that we get once we train our models. We can also use Git for continuous integration and continuous deployment. So we can use different tools like GitHub Actions, or we can, for example, use this tool CML that is specific for machine learning. Another important aspect to consider here is GitOps, that is correlated to infrastructure as code. And this is also a new practice that we are following now. That is to always have all the infrastructure that we need. So If we need a virtual machine, a database, we can specify all these resources as code, and we can build the resources based on this code. And now we have automated testing. So this is also always done for any software product. In the case of ML, we should add to the testing data validation. So here we have to be sure that the schema of the data is the schema that we are expecting, and the values, the input values have certain behavior. So for that, we can have some quality metrics in the validation. We also have to evaluate the model. That is, that all the model metrics, like for example, F1 or any other model metrics, is within the expected values. And we need to do model validation. That is, once we have a model, to be sure that this model is better or is performing better than the current option that we have deployed. In deployment also, it is more complex because it's not only about deploying code that is going to serve users, but it's also deploying a training pipeline that is going to train a model, and that model has to also be deployed within a service that we also need to deploy. So we have different components that we have to deploy, and that makes the whole pipeline or workflow more complex. Now, in monitoring, there are different things that we should monitor. Here we have different metrics, starting from more general, for end-to-end metrics, which are business metrics that can be affected by our models, for example, revenue, or the active users that we have in the system. So if we see that any of that are going out of the ranges, then we should act immediately. We should also track the model performance metrics to see that they are within the expected values. We can also have some metrics monitor integration so that all components are well connected. For example, what will happen if we are not getting predictions, and data drift. For that, there are different tools where we can monitor different statistical metrics about the data. We can have alerts. The most important alerts is if a job is not executed, so we can monitor, have alerts for the scheduler activity, and also for the use of resources, CPU, RAM, or to check what are the requests that we're having to each model that is deployed. So if something is not behaving as expected, we can trigger rolling back. So that is to go to the previous version of the model or the service, or the scaling, that is to change the resources that we have, so that we can, for example, start a new machine on a new service. We have to debug if there is an error in the model, or we may need to retrain the model in the case of data drift, for example, or we may need to do some fixes in the data pipeline. So these are all the different challenges that we have in the normal process. Now we'll talk about some specific practices that machine learning engineers or data professionals have developed to make the ML process better. So here in data, we have feature stores, which are repositories to contain all different features. And the idea here is to have the same exact features for training and for inferencing, so that we don't have inconsistent problems. Also, to be sure that if in a company, different people are working different use cases, we can reuse features. So that the feature store will manage all the metadata, so the description of every feature, from where like who created the feature and how the feature is calculated. And in some cases, we'll also do the computation, so all the transformation of the features. So to have finally whatever we will, or the data scientists will use. There is another component that we have, is the ML metadata store, that will be always saving every time the ML pipeline was executed. It will save when was executed, what was the inputs. So everything that we normally track in experimenting, this will do it for every time that the pipeline is executed. We'll have reference to the artifacts, so to the models or the input data, and to previous versions in case we need to roll back. And we have the metrics in the training and the test data set. And for model management, we have the model registry. It's a different component. It's a collection of models that we need to, or it's a good practice to save for tracking and for deployment. So once the model is tested, is evaluated, validated, we keep it because we know that this model is a candidate to go to production. And we will save along the model, who was the author, what type of model it is, with version, and in which stage the model is. And again, it will have reference to the data, the code, of the parameters that were used to create this model, and all the metrics and artifacts that are related to this model. Now let's talk about model evaluation. Why we do it? Of course, because we need, or we want to have a reliable system. For that, normally when we're experimenting, we start always with a simple model, and then we start adding more features or more data according to what we are seeing. Also, when we are debugging, we have to evaluate the model. And also during, once the model is also deployed in production, if that is happening automatically, so the pipeline has to evaluate the model and report if the model is not performing as it is supposed to do. This is model evaluation, so what we do locally when we are experimenting, or what the pipeline will do if we have an automated pipeline. Additionally, we need to have, in many cases, or it's the best practice to do online evaluation. So while the model is predicting or giving, for example, recommendations to users, we can have some metrics to evaluate. This is done because we have to be sure that the model is performing better than a baseline if there was no model before, or it is performing better than the previous versions. In some cases, we also need to have some models for different clusters or different type of users. And sometimes it's also important to know, how often we need to train the models. How can we do this? Like the most common option is to do A/B test, which is to compare two models or two variants. And we expose these two models to randomly to different users and see which group of users is performing better according to a metric that we predefined. The other option is to use bandits. That is very similar. The difference is that we start assigning more users to the model that is performing better. And canary release, that is to roll out to a percentage of users If we see that the model is performing well, then we will deploy to all users. Another important aspect that data practitioners have to consider is fairness. So to be sure that our product doesn't have any bias, for that we can't use the same tools that we use to evaluate or test our data. And explainability. So we may need to have also tools in place to be able to explain to a user why a model did a prediction or made a decision. And now let's talk about continuous training. So as we saw, we want to monitor our models, and whenever there is an error or something that is not expected, is not working as expected, we want to retrain our models. So we know that models might will decay if we don't retrain them often. So we want to be able to trigger retraining if that is happening. Also because we have new data. As we get new data, we want to retrain to for example, be able to give predictions to new users, or if we have new products coming to our catalog, we want to include them. This is a technical challenge, because we have to be sure that we are getting data as fresh as possible, and we have to be sure that we can't, once the model is retrained, we can evaluate it and be sure that this model is really better than what we had before, or is solving the problem that we have. It is important to consider when we are designing the system is if we want to have batch or online training. So batch is when we wait to have a certain amount of data to train, or online is from every time that we have new data, we are updating the values of the system. If we want to have stateless or stateful training, stateless is when we always retain the whole model, or stateful is when we do incremental, so we get new data and we update only the values. Of course, not all algorithms allow us to do stateful training, so we have to decide according to the model that we have and our use case. And we have to consider also where we will trigger retrain. So we will have simply a scheduler, so we will retrain every day at the same time. If we do it once we have new data, or when there is performance decay or data drift. And according to that, then we have to design our retraining pipeline. So now let's we saw all the components that an ML system can have. As I mentioned in the beginning, so the idea is to see how can we start following the ML process. So here we have the MLops maturity model. So how we can start from not having MLops to have like fully automatic workflow. So normally when you start a company, maybe you have one model and the team is small, you don't have tracking, you have to do a manual training and evaluate your model, and there is no monitoring. And so normally the data scientist is working apart and maybe sending the final file to other people who will be in charge to deploy the model. Then you can start having, for example, there is a data engineer, or the same person can start creating data pipelines so that you don't have to process the data, but you will get already the data clean to train the model, and having some test for the deployment and also for the service. So normally you will have a model who will be like the backend for the service, and then in that case you will have DevOps but not MLOps. Then you can start doing automated training. For that, then you can start using tools to track experiments. You will manage your compute, and you will have a training pipeline. But still, there is, so the data scientists will have to manually evaluate the model. Then we have automated model deployment. And here we start doing model testing and validation, or online validation also. And there will be a continuous integration deployment to deploy a new pipeline who will retrain the model. And we'll have automatic release. In these last stages, then data scientists, data engineers, software engineers need to be working together. So following also the principles of DevOps. And the last stage is full MLops, when we have a retaining fully automatic. So this is how it looks when we have an automated pipeline. So here we'll have orchestrated experimenting. So we are tracking it, our experiments and version of our code, our data. We will be keeping our source code. And based on that, we will be building and testing all the components of our pipeline. We will have deployment of that pipeline. And whenever there is a new training model, this will go to the model registry. And there will be also, we'll have continuous deployment also for the model server, which is normally an API or any other service that we have. All the values or the metadata of the experiment or the pipeline will go to the ML metadata store. And we will be monitoring the production service. If we see data drift or performance decay, we will trigger retraining in this case. And here we have our feature store that is used for experimenting and also for with the automated pipeline. So here we see how all the components that we talk about work together to have a fully automated workflow. So what did we learn today? So we learned what is MLOps. That is a set of best practices. Why should we follow MLOps practices? Because otherwise it's very difficult to really deploy data products in production, and it will take a lot of time to do it. What do we need to do MLOps? Then we need to have support from the technical team in our companies. We need to be able to have a team with different skills and be able to get the tools needed for this. Now, to start following on MLOps practices, we saw the maturity model and how can we start adding different components as we evolve. Of course, that depends on the resources that the company has and the team and the priorities also. Many use cases you cannot really deploy unless you are doing retraining, because you really need to retrain often. And this, depending on all of this, then the requirements will change. Finally, I would like to recommend these two books, which content or are also the source of many of the topics that we talked about today. And these are the links to the main sources. I would like to recommend especially the fourth link. It's a repo that contains all different machine learning tools, and you can choose, you can see according to use case, different options of the repos or open source projects also to use for every component. I'd like to just to give a little more context, also because in the when we did the original session of this talk, most of the questions were about tools. So I would like to mention some tools according to the component that are really useful, and also helps for you to really apply whatever we discussed today. So for orchestrated experimented, we have MLflow that initially was created for that, for experimented. And we have DVC that was originally created to track data, but now it also has ways to do experimenting, to track experiments. We have also a platform that is weight and biases, where you can track weights. That has this name because I was created in the beginning also for deep learning. For continuous integration and development, we have CML that is from the same creators of DVC. We have Metaflow and Kubeflow that are orchestrators. Kubeflow has many more, can cover other components like model serving. For model serving, we have Bento.ml and Seldom, which are tools that will help you to deploy an API or having, after you have the model, to create an API easily. And not only create an API, but deploy it and the service. For monitoring, we have some evidently an EML, which help to monitor data drift and also the performance of the model. And deep checks that is more focused on checking that the data is has the distribution that we expected and all these statistical metrics that we have. And these are some feature stores, FIST, Tecton, and feature form. One of the most common is FIST. These feature stores, like FIST in this case, for example, is open source. Most of these here are open source. And if you combined some of them, then you can have an ML platform. Of course, we have also the services provided by Amazon. We have a SageMaker that covers most of the components that we saw today. And the same is for Azure Machine Learning and Vertex AI, that is the Google product. And they all are meant to offer a full ecosystem for all any ML product. Of course, if you choose one of them, then you are it's very difficult then to change. So normally you have then two options, or choose one of these tools, of these three services, SageMaker, Azure, or Vertex, or go in open source and then build your own ML platform. With that, then you can deploy whatever you want and use combine the different tools according to your needs. And with this, I would like to finish. I hope you will have learned something useful today.